Hello everyone, welcome to my YouTube channel Shilpa Data Insights.
Hello, everyone. Good morning, and welcome to today's insightful workshop on transition into data engineering. It's wonderful to see so many of you here ready to learn and take the next step in your career journey. I am Preeti and I'll be your host for this session. Today's workshop is designed to help you transition into data engineering role. Whether you come from a non-IT or IT background, you'll gain a clear step-by-step learning roadmap to understand what skills to build, how to approach your preparation, and how to position yourself confidently for opportunities in this field. Now, it's my pleasure to introduce our speaker, Ms. Shilpa Das. Shilpa is a seasoned data engineering leader with over 10 years of experience in architecting and delivering large scale data platform using Azure, Databricks, PySpark, Python, and SQL. She has expertise in designing end-to-end ETL pipeline, lakehouse architecture, and enterprise data solution. Beyond her corporate experience, Shilpa is deeply passionate about mentoring and helping professionals transition into data engineering role through her workshop, YouTube tutorials, and career guidance programs. She has helped thousands of learners build real-world skills, prepare for interview, and accelerate their career in modern data performance. We also have our dedicated Q&A segment towards the end of the session, so feel free to share your questions in Q&A tab. With that, I would now like to hand over this session to Shilpa. Over to you, Shilpa.
Thanks, Preeti. Thank you so much for a nice introduction of myself. I'm really impressed with that. So, I would like to introduce myself as per my perspective so that everyone knows about me, and then we can start with our agenda of today. So, my name is Shilpa Das. I'm working as a data engineering manager in one of the big MNC company. And my key expertise is in basically building large scale data pipelines and designing and architecting the enterprise data systems. Now, if I talk about apart from my work, which I do on daily basis, I also mentor students who actually want to transition into data engineering field. So I have a lot of workshops, my YouTube channel, through LinkedIn posts, through blogs, as well as basically from TopMate, I go ahead and mentor students. If in case you really want to transition, there are a lot of things to learn into data engineering field, and quite mentor basically like me or anyone will really help you in transitioning into this field. If you are really interested, you can also like get in touch with me on LinkedIn or on TopMate. So I have a lot of courses there. You can definitely enroll it there as well. So let's get started with today's agenda. How exactly is data engineering field, how exactly you can transition. We will also have a real hands-on in Databricks so that you get to know exactly how daily use cases works, right? So let's get into the agenda of today. I'll just share my screen. Let me know once my screen is visible as well.
It is visible.
Okay, amazing. Okay, so first of all, let's try to understand exactly the data engineering field. Why exactly anyone wants to learn data engineering and go into this field? Everyone knows that you need to learn SQL, you need to learn Python, and you get a very good salary. It could be from 20 LPA, it could be an 80 LPA, but that's not the motto of data engineering field if you want to go. So, why exactly the data engineering role exists? So, if you think about companies like Netflix, Amazon, Uber, PepsiCo, any company, it generates huge amount of data. It can scale from terabyte, petabyte, or more than petabytes of data every day. Now, in order to manage those huge amount of data, you need some system. You need some system which will actually process those data and put that data into such a format that the data scientist or business analyst or the stakeholder can gain some insight out of it. Because whenever your data comes, it's not in a structured format. You have to structure it in a way such that the data scientist can build some insight out of it. Now, what the job really looks like, it's not just writing SQL or Python code. In this job, you have to build an end-to-end pipeline which needs to be scalable. And if in case there's any data issues, you need to fix that data issues. And the data that you are delivering, you need to make sure that the data is accurate, so that whenever there's some data insights, it comes properly. Now, who actually need to pursue this career? So there is no foundation in pursuing this career. Anyone with logical thinking and have patience to learn the fundamentals of data engineering can go into this field. Even if you are a fresher or an experienced, you can definitely transition into data engineering. Now let's start with the roadmap. So at the end, I will show you what is the roadmap basically to get into data engineering. It's not only SQL and Python, there are multiple more things. So we will cover this particular thing at the end. Now, what data engineering really is, it is basically when you get a lot of data, it is not in usable format. The data could be in a CSV format, could be a text, could be an audio, anything. It could be unstructured, could be structured. So you have to actually structure the data in such a way that that particular data can give you some insight. For that, you have to build a pipeline end to end so that the data is transformed from source to target. And while transforming or processing the data, you need to go ahead and make sure the data is valid. Whatever format of data you need, you are providing that data format to the data analytics team or the business reporting team, or you are creating a dashboard or Power BI. So that data is very important. As there is a proverb, I remember that data is oil. That proverb was 10 years ago, and that is true today also. And with AI, I think this is much more true nowadays, right? So that is actually data engineering is. So let's talk about why the company need data engineers. So as we were saying, the data is not structured, and if you give that particular data which is not structured and which is not in usable format, then the business decision can actually go wrong, right? It can lead to incorrect data leads, which can lead to incorrect decision, which is very dangerous. So you really need to give the data in a proper way for the business decision to happen. And that's why this data engineering field is the most demanding field nowadays. Now, who can enter the data engineering? As I was talking about, anyone who want to learn need to have a logical thinking ability and should have a patience to learn data engineering. So if you are a fresh graduate, then you can learn the basics of data engineering. Along with it, you can work on a project end to end so that you learn exactly what data engineers do. Now, if you are a QA or a support engineer, you already have that ability to debug and basically troubleshoot the system. This particular skill set is very much required in data engineering field as well. So let's say the data is not accurate and the data team comes to you saying that the data is not accurate, please fix this up. So in that case, your troubleshooting skills will play a role. Now, if you are a BI or reporting professional as well, then you already have the data logic, the domain logic, and you can upskill it into engineering field very easily. And apart from that, if you are a backend developer, front-end developer, you are definitely familiar with APIs, system architecture, concepts, everything. So if you are aware of these concepts, then you can apply these concepts into your data engineering field and can transition into this field very easily. Now, let's come to the major part of data engineering. That is, what is the core skill required? First skill that is required is SQL. Whether you are a data scientist, data analyst, or data engineer, SQL is a must to know. Why? Because it's used on daily basis for querying or validating the data. Now, if you talk about Python, that is also very much required because you are not writing the code every day. You are automating your task, your processing, and workflows. So, for that, Python is required. Then comes is the very basic and very important core skill, that is Spark. So we will cover in depth what is Spark, but Spark is used when the data set has grown massively beyond a single machine. So you actually have to use Spark in order to process that particular data. Then comes is the data modeling basics, means you have your tables and you have to link the tables with one another. In that case, you need to learn the data modeling basics. The next or the last thing that I would say to be a data engineer is a cloud platform. Either it could be an AWS, Azure, or GCP, any cloud platform you go ahead and pick, but you need to learn at least one cloud platform. Now let's talk about the big picture, how exactly the data is flowing from source to target. So you can have multiple source system. The source can be an e-commerce app, for example, Amazon, right? You are purchasing some products. It could be APIs, it could be any database or any logs that are produced by the system. So it can have multiple source systems from which you can pick the data. That raw data, you need to store it somewhere before processing. For storage layer, you can use a cloud service or you can use data lakes where you are actually saving your raw data. Once raw data is available, you have to process that particular data with the help of SQL or Spark. And after the processing is done, the data is now ready to be consumed by the BI team or the stakeholders. They can create dashboards and analyze on the top of the data that you are providing. So now you think of you are a backbencher in this. You are providing the data and the analysis of the data is being done by the stakeholders or data analyst or reporting players, right? So now let's talk about the next thing, that is SQL. So SQL, if we see, it's the bread and butter of every data engineer. Why is it so? So let's say if you know SQL, you can extract the data very easily. You can filter out the data. If you have a large data set, you don't need the whole data set to actually do an analysis. You can filter out the data, the large data, and make it consumable to, let's say there's millions of rows, you can make it to 100 of rows as per the requirement. Now, if you have multiple tables, because in one table you cannot store all the data. For example, there's a customer table, there's an order table. So you have to pull some data from customers, some data from orders. So in that case, you need to join both the tables. And after joining, you need to actually do some aggregations on the top of it, right? So you are combining the data and you are actually aggregating the data as well. Then comes the windowing function. So this is a very important thing to be learned by data engineer. What is exactly windowing function? If you want to perform any calculation across the related rows, then you will require windowing function. And if the data is in such a way you have multiple nulls or you have duplicates, that data is not accurate or correct. You need to go ahead and handle your null values. For example, you can replace the null values to a particular value, or you can mark them as error records, and you can remove the duplicate values if you have any duplicate values. Now, once you have all these things, the last thing, which is the most important, is the data validation. For example, you have a lot of data and you want to verify whether the totals are coming right or not. So, for that, you need to write some test cases or data validation queries in SQL. So, I would say SQL is the one most important thing that you need to go ahead and master before becoming a data engineer. Now let's come to Python. So Python for data engineering is like you can automate your task with the help of Python script. And if you have multiple files, for example, you have CSV file, you have JSON file, you want to read these files, you can do it with the help of Python API. Now, let's think about example where you have multiple data sources, and these data sources are third party data sources. So you need to have an API connector to connect to these data sources in order to fetch the data with the help of API. So that is where exactly the Python plays a major role in this particular field. There are multiple other use cases, but these are the major use cases for Python for data engineering. Now, let's talk about big data. So, as data is growing massive, there was a concept that was built by Yahoo, which was Hadoop. So, Hadoop is nothing but it's a distributed framework that actually stores and processes big data across cluster of machines. So if you think about Hadoop, it's not a one machine, it is a collection of multiple machines. Like you have multiple machines to store the data. So that is called Hadoop distributed framework storage. So in that, you are storing multiple data into multiple machines. Now, if you want to actually process that data, you cannot do it with single machine because data is stored in multiple machines. For that, you need cluster. Cluster is nothing but collection of multiple machines which have RAM, CPU, and memory. And how exactly you can query and get some output out of these data in Hadoop using the help of Hive. Hive is nothing but it's a similar way of querying SQL. So it's like an SQL like querying. So it uses the SQL syntax itself so that you can actually query the data and get the output from it. So that is what exactly is Hadoop. Now we can talk about the major thing, which is Apache Spark. So, what is Apache Spark? If you think about data is stored into multiple machines, you need a way, a framework to basically process that particular data which is stored in multiple machines. And that's why this Spark came into play. So Spark will enable you to do a parallel processing of massive data set which is across the cluster. So this processing can be either a batch or it could be a real time streaming. So Spark is capable of handling both of them. Now, the next thing that you need is PySpark. So, if you think it's very simple, if you have Spark integrated with Python API comes as PySpark. So, you need to know Python plus Spark and write the code in basically PySpark. So, which we will go ahead and cover it in our hands on how exactly the PySpark works and some use case related to it. Okay, so let's talk about some benefits of PySpark processing. So as we talked about that PySpark processing is used to go ahead and process massive amount of data which is stored in multiple machines across cluster. So to process that particular data in a very fast way, there is a functionality called in-memory computation. It means whatever processing is being done by PySpark, it's done in memory. So what it will do is it will improve the speed of processing as compared to the disk-based systems because everything is in memory right now. In PySpark, there is one more concept which is called fault tolerant. What does that mean? So as we talked about, there are multiple machines. If one machine, which we call it as node, fails, then it automatically replicates the data stored in that machine in a secondary node machine. So now, if it fails, we have not lost the data. We do have the data and we have a lineage of data. So it does not have to recompute the data, whatever it has computed before. It can just go back to one, let's say the one data frame, and it can recompute it. I'm using these terminologies like data frame, which will definitely cover in the hands on. You will have more clarity what exactly it is. Now, the next thing that we have is the transformation and action. So, what exactly is a transformation? Transformation means it is going to transform your data, as the name suggests, and it's going to return a new data frame. It's not going to give you the result, it's not actually computing anything, but it's computing in the memory, whatever the transformations have been done. Once you call an action, action means you are, let's say, eating, that's an action, and transformation means you are thinking something, okay, I will go ahead and eat, that's a transformation. Now in the action, exactly the trigger of the execution happens, and then it shows you the output. So that is what is the transformation in action. These are the basic concepts of PySpark processing that everyone should be aware of to actually write the code and build an efficient system. Now let's talk about what is Databricks. If you have heard about Databricks, it's a very popular framework right now that every company needs. Why is it so? It is because it's a first thing is it's a cloud-based unified analytical platform, which is built on the top of Apache Spark, and it is used to basically process the data. So Databricks is nothing but it can be on the top of AWS, Azure, and it has the Apache Spark capability. So with the help of a click of a button, you can create your cluster and you can write your code and execute it. The second thing, why is it famous, is because it provides a collaborative environment for data engineers, analysts, and data scientists. So everyone can work together in this particular environment to build their pipelines and deploy their pipelines. And the third most important thing is you don't need four different interface in order to write four different languages. So it has a concept called where you can natively support all the languages. Like you can write a code in Python, you can write a code in SQL, you can write Scala, and you can write R in the same Databricks notebook. So it's actually very versatile if you think. So in a notebook, in most of the cases in Python, you cannot write, right? You just need to write a Python code. But in Databricks, you can write Python and SQL at the same time. So let's talk about what is the core component of Databricks. So the first core component of Databricks is workspace. So workspace is where basically you have your notebooks, dashboards, and libraries. So notebooks where you are actually writing your code. Dashboard is something where you are visualizing the data set, and libraries are, for example, you want to install any library, a third party library like Python, so you can do everything in the workspace. Now let's talk about cluster. So cluster is nothing but an compute resource. It's a collection of compute resource which you can go ahead and create with just a click of button. You just have to mention what cluster size you need and it's going to create it. So we will see this in practical. Then let's talk about DBFS and data lake. So what is DBFS? DBFS is the distributed file system itself, which is being provided by Databricks. It's internal to Databricks, where you can store the data and you can use that data. And this is actually integrated with the cloud storage for managing the data sets at scale. So DBFS is very important because if you have a small data set and you want to store it, you can do it with the help of DBFS. Now let's talk about jobs. So jobs is nothing but you have series of tasks that you combine it together to create a job. And this job you can automate, you can schedule, and you can orchestrate for the production pipelines. And if there is any recurring data workflows, you create that job and you schedule them basically. So the next major concept that we have here is Medallion architecture. So in Databricks, what we have started following is three-layer architecture, which is called Medallion architecture. So the first layer is a bronze layer. So in the bronze layer, we have data. Let's say you are getting the data from a source. You have a raw data which is not in a structured format. So whatever raw data you get, you are ingesting that data from the source system into the original format itself in the bronze. Now, once the raw data is there in the bronze, you can actually do a cleaning of the data, validate the data, or transform that data. And you can have some quality checks applied to it. So, all this activity is actually done in the silver layer. The next layer that we have is the gold layer. In the gold layer, you do all the aggregations of the data set, which are given by the business requirement. And this particular data set is then used for analytical and reporting purpose. So gold layer is mostly connected to the downstream applications like the Power BI, Tableau, or any table or database that is getting used for analytical purposes. Now, the last thing, a core concept that is required is the cloud. So you can pick up any cloud, as I was mentioning, you can have an Azure, AWS, or GCP, whichever feels fast to learn and good to learn, you can pick it up because all of them have high demand in the market. Now, if I talk about Azure, which is being provided by Microsoft, you need to learn three basic concepts of it. One is the storage, which we call as ADLS, which is called Azure Data Lake Service. In this particular storage, you can go ahead and store your raw data or process data or your gold data. So any kind of data, you can go ahead and store it in ADLS itself. The second thing that you need to learn is data factory. Data factory means you have a list of tasks that you want to automate or that you want to go ahead and run one by one. Then you can build a data factory or a pipeline with the help of data factory. So that particular pipeline is created in a service which is called Azure Data Factory. In Azure Data Factory, once you create a pipeline, you can also automate it or schedule it as per the time that has been provided to you. Now let's talk about Databricks. So what exactly is Databricks? Databricks is nothing but it's a processing engine. So as I was talking about Databricks, it's basically a cloud integrated platform where you can go ahead and run your Spark jobs without any infrastructure deployment. So that is the capability of Databricks, and that is integrated with Azure. So let's say you have stored some data in ADLS and you want to process it with the help of Databricks, you can do that as well. Once the data is processed, the next important thing is the reporting. So Azure also provide a functionality in reporting, which is called Power BI. So in Power BI, you can create your dashboards and go ahead and give it to the business users to basically gain some insight and make some informed decisions. Okay, so we have covered a lot of things till now. Now, the next important, I would say, that you need to learn, not in depth, but at least the basics, is the data modeling. So, what is data modeling? Data modeling, as the name suggests, is a data model. What is a data model? Data model is nothing but where you are creating, organizing your data in a structured way. So you can think of data model as they are tables. You are saving your data in the tables, but you cannot have isolated tables or data, right? Every table needs to be linked with another table with the help of the keys. It could be a primary key, foreign key, and so on. Now, there are two types of table. One is fact and second is dimension. What is a fact table? Fact is any event that is occurring. It could be a transactional event, it could be a sales or payment. Those transactions are actually called as facts, and those needs to be stored in the fact table. Now let's talk about dimension. So what exactly is a dimension? So if you only have a sales data, you don't know what that sales data represent. That sales data can represent a particular date data or a customer's data, right? So that descriptive detail of that particular fact is actually stored inside a dimension. So these two are very important concepts of data modeling that you need to learn. Now when you are building a data model, you need to make sure that it's actually scalable, and the table design actually have some structure which needs to be performant whenever you are querying the particular table. So if you see this particular diagram, this is a very simple diagram how exactly the data model looks like. So you have a product table, you have a customer table, and you have an order table. This is like, let's say, an e-commerce data model itself in a simplified way. So the product is linked to an order table with the help of product ID. The customer is linked to the order table with the help of a customer ID, right? And that particular order table also have a date ID, but we are not maintaining the date complete thing inside the order table. We are maintaining a separate table in which we will have a date ID, a full date, what is the month of it, what is the year, what is the quarter, and so on, right? So you see, all the tables are not independent, they are linked to each other with one particular key. So this is what exactly is a data model. Now, if I talk about the use case across industry, there are multiple use cases. It as the data is produced by every industry, it could be a financial service or healthcare. So if I talk about one use case of financial service, it's very important, which is the real time fraud detection. Or if in case there's a risk analytics, that is very famous use case of financial service. In healthcare, we have a lot of data related to patient, right, related to health management, clinical research pipelines. So we can go ahead, create projects behind this healthcare as well. Then talk about retail and e-commerce. If I talk about e-commerce, I think the first thing that comes into the mind is the Amazon, right? So you get Amazon as your base, and you think of it like you have customer behavior analytics. You can design a project in that. Then you have inventory optimization and personalized recommendation engine. Then you have manufacturing. For example, any manufacturing company you pick up, there is a supply chain, demand optimization, or predictive maintenance. So these are some use case across the industry. So now let's go ahead and just check about the practicals, in which we will cover something related to SQL and PySpark, and then we will come back to the slide to cover some important topics like how you can prepare for the interview, what all projects you need to do, and what all mistakes you need to avoid if you want to land into data engineering job. So let's go to the practicals. I hope my screen is visible, right?
Yes, yes.
Okay. So let's first talk about this Databricks as we were talking here. So we have a workspace. So in this workspace, you can create your notebooks. So if you will see in this, I have my user and I have these notebooks basically created, right? Similarly, you can create any notebook. It could be an SQL or a Python notebook. In the recent tab, you will see what all recent files and folders you have created. In the catalog, what you will see is what tables you have created, what databases you have created, or if in case you have stored any file. Databricks provides some sample file which you can definitely go ahead and practice it from there. That's why it provides. So these are some tables for quick start. Then comes is the jobs and pipelines. In the jobs and pipelines, if we see, we can create a particular job with the help of this create option, and it will go ahead ask you which particular notebook you want to attach in a particular task. So if I click on this job, you will see this kind of interface. It will open and you can create a notebook and attach it here, and you can add another task. Then comes is the compute. Compute means it is the cluster. So you have multiple machines that you can go ahead and use in order to run your query. So that is what is the compute. So Databricks provides a serverless starter warehouse, which is exactly a compute here. Now let's go to our notebook that we will go ahead and query. Okay, so in this particular notebook, let me first start my cluster. So my cluster is running. So I will be using a use case of e-commerce itself. You can think of any e-commerce website that you are using. In the e-commerce website, you have a customer, like you are a customer, and you are placing an order. So I'm creating two tables here. One is the customer table, and the second is my orders table. So once these two command run, it has created my table. So how you can write is you have to mention what all columns you need in the table. So my customer ID, name, city, sign up date are my columns inside my customer table, and this is my primary key. Now, in the orders table, we have order ID, customer ID, order date, and order amount. And this is my primary key. So once these two gets executed, we need to insert some data into these two tables. So I have created some dummy data. So with the help of insert into syntax, you can go ahead and insert the data into this particular table. And similarly, you can insert the data into the orders table. Once the data is inserted, we will run the query in order to see what data we have in the customer and what data we have in the orders. So there are total 6 rows in the orders table and 5 rows in the customer table. So how you can fetch all the data of the customer? You can do a select from customer. If you need all the data, you put a star here. Star means you are pulling all the data from the customers table. Now, let's say we have this particular 5 customer ID, but I don't need all the data. I need just my customer name and my city. So how I can pull only customer name and city? I can pull it with the help of customer name and city in my select clause. Instead of star, you can put customer name and city from customers. So this is how you can pull your customer name and your city. Now let's come with the, you have to find customers from Delhi. What does this mean? So you have some customer, you have some city. So you have to find the customer who belongs to Delhi. So Neha and Rahul here, I can see they belong to Delhi. So what I will do is I will do select star from customer. So it will give me all my columns where city is equal to Delhi. It means it is going to filter out the data where the city is actually Delhi. So you see, it has given me Rahul and Neha, and my city is Delhi, right? This is how you can filter all the records where the city is Delhi. Now, the next thing that we will be doing is to show all the orders placed after 1st of Feb 2023. Now, if we will see what is my orders table here. Okay, let me first query my orders table because I have not queried it. So I'll do select star from orders. Okay, I'll run this query and see who have actually placed the order after 1st of February 2023. So I could see after 1st of February, we have this 15th of February, we have 5th of March, 25th of March, and 10th of April, right? So I need all the records. So how I can do is I can filter out the records where exactly the order date is greater than 1st of Feb 2023. So in my where condition, I'll put this order date greater than this, and I'll do a select star from orders. So this will give me the result data set. So you will see all the orders are greater than 1st of Feb 2023, right? For all these order ID. Now, the next thing, let's find out the orders where amount is greater than 5,000. So if I see my data set, we have amount 5,000, but I need wherever the amount is greater than 5,000. So for example, this 7,000, then we have 10,000, then we have 8,000. So what I will do is I will just go ahead and run this command where the order amount is greater than 5,000. See? So I have got my result data set. It's the same concept where we are actually filtering out the data. Now let's go ahead and count the total number of customer. So to count the total number of customer, we are using the from customer condition, and we will use this particular functionality, which is called count star. It means it's going to count all the rows which are present inside this particular customer table. So how many rows are there? There are 5 rows as we were showing in the above screen. So we have total 5 customers, right? So that's what it showed me in the result data set. Now let's find out the minimum and maximum order amount. So we have this functionality, which is called minimum. Inside the minimum, you put your column name that you want to find the minimum for. And inside the maximum, you put the column name that you want to find the maximum. So you have select minimum and maximum as minimum order from orders. So if we see here, their minimum amount is 2,000 and the maximum amount is this. So I will just correct this because this is my maximum amount and this is my minimum amount, right? So let me rerun this so that the clarity is here. So this is my minimum amount and this is my maximum amount from my orders table. So let's see how you can find the distinct city where the customer are living. So if you need to find all the distinct city, it could be Delhi, Bangalore, anything. So you can use this distinct keyword. It is not going to give you any duplicate, only unique values of the particular city. So there are total 4 cities in which the customers are living, in which they have placed the order. Now let's see how we can find orders between 2 days. This is actually very important because it's been used widely. So if you want to find any order between 2 days, we have this condition or this clause, which is called between. If you put anything after between, so between 1st of Jan 2023 and 1st of March 2023, it's going to give you all the result. And this 1st of Jan is inclusive and 1st of March is also inclusive. So anything which is between 1st and 1st of March, it's going you to give that result. So you see, this is 20 January, 15 Feb, and 10th January. So it has given me all the orders where this order date is between this date and this date. Now we have 2 more concepts here, in which we will find the total spending per customer. If you read this question very carefully, you have to find the total spend per customer. So every customer who are spending, we need to find the total. Now we have 2 table. If you remember, one was customer table, another was the orders table. So you have to find the customer name and the total amount. Total amount, you can find it from the orders, right? So if I see here, we have the order amount in the orders and customer name in the customer, but we have this common key, which is my customer ID. So we have to join both the tables, that is my customer table and my orders table. So how exactly I want to do a join? It is actually an inner join. So with the help of my inner join, I'm joining customer and order, and on what column or on what key I want to join. This is my primary key, which is the customer ID, because customer ID is present in both the tables, right? So I will go ahead and join customer with order with the customer ID. And I want to calculate the sum of it, the order amount, which will be actually total spend. But how exactly I want to calculate the sum? I need to group it by each customer. Then only I need to calculate the order amount. So if I show you here, it will give you the customer name. For example, Neha has spent total amount as 8,000. So it has calculated for each customer how much amount is being spent. Okay, I hope this is also clear. There are three things that is being used here, right? How exactly to do the sum, how to do a join, and how to do a group by. Now, the next thing is, if you want to find the top two customer from this particular list, how you can do it? You can basically order it by the total spend, and you can limit it by two, and it will give you the top two customer, because you are ordering it by total spend in the descending order. So if you will see, 14,000 and 10,000 is the top two customers, right? So these two are the top two customer, and it has actually ordered in descending order and gave you the result. Okay, I think this is all for SQL hands-on. Now let's start with the PySpark hands-on. It's the similar use case that I will be taking, so that you can compare the SQL and PySpark efficiently, and you can write the code easily as well. So in this, I will be creating my orders data. If you will see, I have this particular orders data, and these are my orders column. Okay, and I'm creating a data frame out of it, which is using the create data frame. So this orders df dot show is there, which is my data frame, and this is my orders table. Now, the next thing that I will be creating is my customers data frame. Data frame is nothing but is a way of displaying a Spark data set, okay, with some unique columns that it has. Now, let me show the orders data frame. How you can do a show? You can do it using the show command. In Databricks, there's a display command as well. You can use that also. Now, the question that we have is filter orders where amount is greater than 5,000. So you have to filter the amount greater than 5,000. So for that, I'm using this filter clause, and where this orders amount is greater than 5,000. And I'm doing a show command. So now you will see the orders are greater than 5,000 here. The next thing is that we will select only customer ID and order amount, as we don't want to do a select star. You can see we are using the select clause itself, which we used in SQL, right? We just need to append the data frame name with a dot and do a select and whatever columns we actually need. So that will help us in getting the columns that we need. The next question that we have is, we have to count the total number of orders. So to count the total number of orders, in SQL, we have count star. In PySpark, we can just do a data frame dot count, and it is going to give me the number of orders. That is 6. Okay, so the next we have is, again, the same question we solved in the other SQL, that is join the customers and orders to display customer name with order amount. So we have this customer name, we have the order amount, and we are joining the orders data frame with the customer's data frame. On what key? We are joining it on the basis of my customer ID. If I do a join, it is going to give me the customer name and the order amount. So customer name is coming from customers DF, and orders amount is coming from orders DF. Now we have to find the total spending per customer. To find the total spending per customer, you have to go ahead and do a group by on customer ID, and you have to aggregate, or you have to create a sum on order amount. So this is the same question that we were solving in SQL. So you do a group by and you do a sum. Only thing that is different here is a little bit of syntax. That is, you can use aggregation and you have to put your column name inside the quotation. So this is our result data set. So let's find the total number of orders per customer. So you do a group by and then you do a count. So that's how you will get the total number of orders per customer. So I think we have a lot of other questions as well here. So this is the same. So I'll not run this, as we will run out of time otherwise. And okay, this is a very famous thing that is used. So let's discuss this point. So we have to find the customers who have not placed any order. So it means there are some customers in the customer table who have not placed any order. So we have to actually find those customers. So to do that, we are joining customers and order, but how exactly we are doing? We are doing a left join on customer ID. And if we do a left join, we are selecting all the data from customers table. And if in case orders table doesn't have that data, it's going to give us the null value. So therefore, we are filtering the data that is order ID from orders table where exactly it is null. Okay, and then we are selecting the customer's name. So this is what is exactly how you have to actually relate SQL with PySpark and start writing the code in PySpark. So let me go back to my presentation here and we will discuss the rest of the topics that we have left. Okay, so as we were discussing, we really need to create some data engineering projects, which will really help us gaining insight how exactly the projects work in real-time scenarios in the companies. So to build a project, the first thing that you need to actually figure out is uh, what exactly is the problem. If you have a problem, then only start with a project. If you are taking a random data set, don't start with a project. The problem could be you have to find the sales of a particular company for this year and how exactly you can increase it for the next year. So that is a problem. Now, once you have identified the problem, you create an end to end data pipeline. You figure out what all ingestion sources are there, and then you go ahead and transform that data and put it into the output. That is the goal layer in Databricks. Once you have the data in the goal layer, then you have to figure out if in case the pipeline may fail. So how exactly to handle the pipeline failure and how exactly to monitor the pipeline. So this will be an end-to-end data engineering project that you need to actually build to gain some insights. Now let's talk about what interviewers really care about. So if you think about interviewers, right, they don't check on what syntax you know, what logical syntax you have for SQL and PySpark, but if you have an ability to actually solve a problem. So that is how exactly you need to prepare for an interview. If you are writing a SQL code, how you can write an optimized SQL code. If there are some edge cases, how you can handle that edge cases. It could be a missing value, it could be a duplicate error, how you can handle them up. And the last thing is you have to have go ahead and articulate your answer very clearly so that the interviewer can actually understand what you are trying to explain. Now, how exactly an interview typically work or looks like? In the first round, mostly the SQL and PySpark problem solving skills are actually seen because in every day you will be solving an SQL and PySpark problem. Then they will deep dive into your resume, in which you will be covering maybe a cloud service or a Databricks or a data warehouse or a data modeling thing. So they will deep dive into resume. And then is the scenario based questions, what all scenarios you will get, and the project explanation, which will be the mostly the last round where you have a hiring manager round where you need to explain your architecture. And now comes the major part is if you are trying to transition into data engineering field, I have created this 90-day transition plan. And this is how exactly it looks like. And it's really beneficial to all the students that I have provided to. So in the first month, you have to learn SQL, Python, and PySpark fundamentals and practice it on a daily basis. In the second month, you have to build at least one end-to-end project on the basis of the problem that you are trying to solve. And the third month, you have to revise every concept and apply it and try to improve on any weak areas that you have before actually appearing for an interview. And the last thing that I want to discuss here is what mistakes you need to avoid. There are so many tools that we have, right? Don't start hopping from one tool to another. For example, AWS, Azure, and GCP, right? If you are learning Azure, stick to it. Don't hop from one technology to another. Now, if you're watching the videos and you're not practicing, you are making a big mistake. You practice as much as you can and watch less. And if you are chasing for certificate, I would highly recommend, don't start collecting certificates without real projects. Make sure you do real projects. And if you are waiting for confidence and avoiding interviews for fear, please don't do that. Start giving interviews once you feel that you are prepared. Now, if you want to, let's say, this is all I had actually. If you want to really connect with me and take mentorship, you can connect. I can give you the link. Preeti can give you the link actually, and you can connect with me 101. And I have a 1 month crash course as well. If you really want to join, you can do that as well with the help of Topmain. And thank you so much for patiently listening to me from start to end. I hope you have gained some insights related to data engineering. Over to you, Preeti.
Thank you so much, Shilpa. And I am sharing your LinkedIn ID here. And if you guys want it later, also you guys can reach out to us. I will share like on over LinkedIn or any Facebook, Instagram. I will share the link with you. And before moving to Q&A, we have one session feedback form which I'm launching from my end. It will take only 5 seconds. Do let us know like any other preference, like what other other topics you want sessions and all. So please, guys, it will not take more than 5 to 10 seconds. So let's take our first question. So Jitendra is asking, can we download and try Databricks for free on our system?
Yes, you don't need to actually download. You can just go to the Databricks website. It's a web platform, and you can register there and you can practice it there.
Thank you. Guys, if you have any question, please put it in a Q&A tab. Okay, Ravi is asking, can we use PHP or Java instead of Python?
For data engineering, I would say it's not recommended because PHP and Java is mostly in basically backend. So right now, its demand is Python. So I'd highly recommend, if you want to go into this field, learn Python, and it's very easy to learn because it's like a simple English language. So you can learn if you actually know Java.
Thank you. Other question, does order line only numerical?
No, order line, you can have the order ID, you can have the order name, you can have the order date. So it need not to be numerical.
Okay, thank you. Another question. I am from healthcare, and we deal with huge amount of data with patients' data analytics. As a domain and SME expert with only information about ETLs and no knowledge in data engineering, how can I play a role in validation and data cleaning?
Okay, so this is really nice that you have a domain knowledge and you are an expert in ETL. So if you think about data engineering, it's a basic thing is the ETL process itself, where you are extracting the data, transforming and loading. The only thing that you need to learn here is, if you are aware of SQL, you need to learn PySpark. Okay, and PySpark will give you an upper edge, and the rest thing you have already learned. So there's nothing to worry. If you want, you can also learn a cloud technology, right, which will help you.
The same person is asking, Shilpa, can you also explain with the advent of AI model, can data engineering expedite it, or does it play a tool for ETLs?
I'm sorry, I did not get the exact question here.
Okay.
Actually, yeah,
Uh,
basically, data engineering will have the ETL tool itself. Okay, so it is extracting, transform, and load, and you need to learn these concepts if you are aware of the ETL technology itself, because ETL is like an old thing, and in the new terminology, it's called data engineering itself.
okay, thank you. Another question is related to AI. With AI evolving rapidly, how do you see the role of data engineers changing in upcoming years?
That's a very good question, I would say. So, AI, if I see that right now, if you are writing a Python code, SQL code, or PySpark code, that can be automated with the help of AI. So, if you were trying to do some task in maybe 1 or 2 hours. Now you can do it in 5 minutes because these capabilities are being provided by AI. What AI cannot provide is the strategical thinking according to the business requirement. So let's say there's a failure in the pipeline and you want to fix that up, that can be done by AI, but you have to put some effort first to figure out why exactly it's failing, and then ask AI to actually fix it. So wherever there's a human intervention, there is your role. Wherever AI can do, let's say the coding, that you can give it to AI and you can improve your efficiency there.
Thank you. Another question is how much SQL is needed to learn to become the data engineer?
So SQL, you need at least 90% because in every day you will be writing SQL code, and it's from beginning to advanced level SQL you will be requiring. So if you are preparing for this field, make sure you're an expert in SQL.
Thank you. Another question, what skill will become most in demand in modern data platforms?
So right now the demand is like the tools are evolving. Right now the demand is Databricks, Snowflake, and the cloud, that is AWS, Azure, and GCP. And the cloud will not go anywhere. So if you are learning, make sure you are learning that. And for now, at least Databricks, you never know what is going to come after 4 or 5 years because it's in a very evolving phase right now.
Okay, thank you very much. Another question, Santosh is asking, do we need to learn Apache Spark as well as PySpark?
So Apache Spark is the foundation of the distributed framework. So if you are going into data engineering, yes, you need to learn Apache Spark. So Apache Spark fundamentals theoretical you need to learn, and for coding, either you use Spark with Scala or you use PySpark. So yes, you need to learn both, I would say, for data engineering.
Okay, thank you very much. Another question, Mr. Feroz is asking, hi, I am network engineer. What is scope for me in data science?
So as you are a network engineer, I think you are a very much expertise in network. And this is if you are trying to go to data science, I'm not sure if you will have these knowledge implemented in data science. However, if you are preparing for data engineer, then definitely these knowledge will be applicable for data engineer as well, because you have to build the data system from end to end where the networking thing will play a vital role. So you can definitely do it, but whatever concepts that I have explained today, please learn these concepts for data engineering.
Okay, thank you. Another question is asked by Mr. Devashish. Are Hadoop and Databricks similar, or it's not a good comparison?
I would say it Hadoop and Databricks are not similar because Hadoop is also was an open source framework where you can write the Hive queries, and the concept remains the same, which is a distributed framework where you are storing the data in multiple machines and you have a compute cluster for processing the data. In Databricks, you have multiple other functionalities. So it is integrated with cloud. So you can store the data in the cloud. And now you don't need a headache to create your cluster. By clicking of a button only, you can create your cluster. You have your CPU, you have your RAM. Now, the next thing is it has a thing called Unity Catalog. So you can share your data very efficiently without any problem across the teams. So the basic fundamentals is same, but it's an advanced level where you have a lot of capabilities to do in Databricks.
Thank you. Another question, are there enough opportunities for freshers?
I would say there are 100% more opportunities for freshers. You just need to develop your skill set very well so that no one can actually reject you to get hired.
Thank you. Another question, is there any portal where we may practice writing pipeline in ADF along with CI/CD using Python?
Okay, so Azure provides you 200 credits So once you log in, you get 200 credits. You can create your pipelines inside the Azure itself. And with the help of Azure DevOps, you can actually do the CI/CD pipeline itself directly. The second thing is, if you want to create the pipeline in Databricks, that also you can do it. But in that CI/CD, you may not be able to do it. That's not in a free version, but definitely you can create your pipeline, you can schedule it, and you can work on it.
Thank you. Let's take another question from live. Yeah. Is certification necessary, or are hands-on skills enough?
So there are some companies who specifically need certification, not all. I would recommend first build a project by your own and be an expert in that before actually applying for any certification. You can do certification at any point of time, but skills are more important rather than doing a certification. Don't chase for certification, I'd suggest.
Okay. Another question. From a hiring manager's perspective, what makes you immediately reject a data engineer candidate?
That's a very interesting question. So it's not that if a hiring manager is there, they are sitting to actually hire people, right? So if they need to reject someone, it's just the ability to think. If they have the ability to think, willingness to learn, that is a very good plus point, and you are hired. But if you don't have these two approach, then it becomes very difficult for a hiring manager to hire.
Yeah, that's it. We are done with the questions. But before ending the session, any piece of advice you would like to give our audience, especially to the freshers who are struggling to get their first job?
Okay. So the only advice is you keep learning. And second is don't lose hope. If you are learning, one day will come where you will have the job, and always have that attitude to keep on learning. Even if you have got a job, still you need to be very much curious to learn. So that will only help you in getting a job and excel inside the job.
Thank you. Thank you very much, Shilpa, for your time. We truly appreciate you taking the time to share your knowledge and your experience with us. It was a great, very great learning experience from you, and really grateful for the effort you have put into making the session so engaging and easy to understand. And also a big thanks to everyone who have joined us today. We hope you found the session helpful and took away something valuable which you can use in your own journey. So, if you'd like to rewatch or share it with your peers, full recordings are also available on our LinkedIn page and YouTube channel. So, wishing you all happy weekend. See you in the next time. Thank you very, very much, Shilpa. Thank you.